pulled into a dock. What cracks me up is the people who draw the dock at the same time as the boat. I've never seen that. That would be a dock in the water. I guess it could happen. This dock is not. Oh, I do not adapt. Every day, guys. Every day, don't grab situation. All right. So we have a boat. Okay, everyone paying attention and writing this down and not playing a game with their phone sideways or vertical. All right. A boat is pulled into a dock by a rope attached to the bow of the boat and passing through a pulley on the deck. So we have a dock with a pulley of some sort. Bow. I just said bow. That's scary. That isn't great. We'll make it as crazy as possible. Because it needs to be higher and it's not. Anyways, we have ourselves a what made out of it? A triangle. Okay, we have a triangle. So a boat is pulled into a dock by a rope attached to the bow of the boat and passing through a pulley on the deck that is 1 meter high. So this pulley here is 1 meter high. Okay? If the rope is pulled in at a rate of 1 meter per second, how fast is the boat approaching the dock when it is 8 meters from the dock? So is the hypotenuse 8 meters or is this bottom one 8 meters? The bottom one is 8 meters. Does anyone know how I can find a hypotenuse from grade 10? Pythagorean theorem. So we're going to have c squared equals 8 squared plus 1 squared. C squared equals 65. Square root. What do we do when we get the square root? Plus or minus. So C equals positive root 65. And C equals negative root 65. And because we're mathematicians, we show both. We circle this one and we say it is. Now, why is it extraneous? But yeah, okay, that's negative. But why is it extraneous? You can't have negative meters. Distance. So we have root 65. Can 65 reduce? No. All right. Note to self. Today we are going to be given an angle, but if we are given an angle, we might have to use SOHCAHTOA, correct? Because it's a 90-degree triangle. This one we're given all three sides, and we are given related rates. We're given 1 meter per second. So that's dH over dt. But of which one? So if the rope is being pulled, so we'll say, I'm going to say that this is A. I'm going to say this is B. I'm going to say this is C. Which of the rates is it for? A, B, or C? C. So they gave us dC over dt equals, it's being pulled in. So is it decreasing the rope or increasing the rope? Decreasing. So minus 1 meter per second. Now we know that we have to take a formula of some sort and differentiate it in order to do some math, correct? If I give you an angle, we're going to take like SOHCAHTOA and then differentiate that. If I give you 3 sides or 2 sides and you find the third side, what are we going to use? We're not finding an area. What formula do we use? With 3 sides, what do you use? Grade 10. Pythagorean theorem. C squared equals A squared plus B squared. And we're going to have to differentiate that. Can we erase that? I don't know. Can you erase? That's painful. Okay. So, if we differentiate this, what do we get? Two C dC over dt equals 2A dA over dt plus 2B dB over dt. And I can only be missing one thing. Which are they making me look for? So they're saying if the rope is pulled in at a rate of 1 meter per second, how fast is the boat approaching the dock? So are we looking for dA over dt or dB over dt?
DA.
So we're looking for dA. So it's the only one I can't fill in, correct? That's what I'm looking for, dA over dt. So let's see if I can fill this in. So 2 root 65 meters. We always use our units. DC is -1 meters per second equals 2 times A, which is 8 meters. dA over dt is what I'm solving. Plus 2B is 1 meter. And then dB over dt I need. How do you know that? Why is it not moving? It's a pole. The pole, can a pole change rate? No, it's just a straight object that cannot change its height at all. So dB over dt equals 0 meters per second because it is a stagnant object that doesn't move. So 0 meters per second. So the great thing about this one is it, yeah, the whole thing. So this one I'm going to be left with -2 root 65 meters squared per second equals 16 meters times dA over dt. How do I get that by itself? Divide by 16 meters. And if you want to show the actual math so that your angles cancel, or your units cancel, we get dA over dt equals -2 root 65. Remember, numerator cancels numerator, go for it. If you don't, flip and invert and multiply. So I'm dividing by 16, I'm going to multiply by 1 over 16 meters, and then this and this cancel. I'm going to be left with meters per second, which is A over T, which is good, right? The 2 becomes a 1, the 16 becomes an 8, and dA over dt equals -root 65 over 8 meters per second. Now, does that make sense that the dA over dt is negative? That the angle of that is reducing the rate of change? Yeah, because it's getting closer to the dock, right? We're pulling it in. If we were releasing it away from the dock, it would be possible. Okay, this next one isn't a boat, it's a ladder. Same diff. You're gonna have a ladder on a wall. So sliding up or down. Go. So for this one, you have c squared equals a squared plus b squared. It says the top of the ladder slides down the wall. So say I say this is a. I would have dA over dt equals 0.15 meters per second. When the bottom of the ladder is 3 meters away from the wall, guys, it slides away, so dB over dt equals 0.2 meters per second. I need to find A, correct? What is dC over dt? What is the ladder's change in rate? If I take a ladder that is one height and I lean it against the wall, what's its changing rate? 0. So this would be 0 meters per second. We agree? So differentiate this, we get 2c dc dt equals 2a dA dt plus 2b dB dt. What is dc dt? What is this? What is dc dt? Shh. What is dc dt? You literally wrote. What is dc dt? 0. What's 0 times anything? So this is gone. So now I have 0 equals 2a dA dt plus 2b dB dt, correct? So I can plug dA dt in for dA dt, leave A be A, dB in for dB dt, B in for B, solve for A, correct? Once I get A, can I not just use Pythagorean theorem to get the Length of the ladder? Yeah, try it out. So, we have 0 equals 2a 0.15 meters per second plus 2 times 3 times 0.2 meters per second. This 3 is in meters on it, sorry. So we get 2, what's 2 times 0.15? 0 decimal. What's 0.15 plus 0.15? 0.3 a meters per second. And then here we get 6 times 0.2. What's that? 1.2 meters squared per second. So that's a plus sign. Okay, so we can subtract that over, negative 1.2 meters squared per second. And then we get equals 0.3a meters per second. Divide by 0.3 meters per second. And this cancels off this. The seconds cancels off this. And what does A equal? Negative 0.4 meters. Then to get Pythagorean theorem, to get the ladder, we do c squared equals negative 0.4 meters squared plus 3 meters squared. C squared equals what? 9.16 meters squared, plus or minus. Okay, so C equals, what's the square root of 9.16? No, what? This should be 4? I just trusted. 4 is a lot better. Oh wait, that gives you a much nicer answer. Okay, what's 16 plus 9? Okay, then we have to say, shh, the ladder is 5 meters long. It doesn't even make sense if that sentence is negative yet.
The speed rate is the bottom rate is positive and the wall rate is on the section.
Oh, it's sliding down. Yeah, this should be negative. Yeah. Yeah. I believe you. What? You divide by a decimal, it's bigger, right? All right. These 2 questions.